All right, let's jump right in. Today, we're doing a deep dive into a really powerful solution for modern data centers, Cisco's ACI multipod. We're going to break down its architecture, the protocols that make it all work, and the different ways you can deploy it, all based on Cisco's own official overview.
So, here's our game plan. We'll start with the why. Why does this technology even exist? Then we'll get into the nitty-gritty of the architecture and protocols. After that, we'll look at some real-world deployment scenarios. And then, and this is super important, we'll walk through what happens when things go wrong and how you can design a resilient network. Okay, first things first, let's really nail down the fundamentals. What is ACI multipod? And more importantly, what problems is it actually built to solve for you in your data center? So let's get right to the heart of it. What are the big challenges you might be facing in your enterprise that would make you even start looking at a solution like ACI multipod? Why bother? It really boils down to three big things: scale, resilience, and operational simplicity. As your data centers grow, you might need to stretch across multiple server rooms or even different buildings. Multipod is designed for exactly that. Whether you're setting up an active disaster recovery site or you've just plain outgrown the 200 leaf limit of a single fabric. And the best part? You manage the whole thing from one place. So the core concept here is pretty elegant. You take multiple physically separate ACI fabrics, we call these pods, and you stitch them together so they act like one big logical network. This is a game changer because it means you can manage data centers that are miles apart as if they were all sitting in the same room. And this picture gives us that perfect bird's eye view. You see the individual pods, right? Each one is its own leaf and spine fabric. They're connected over this dedicated backbone, the Interpod Network, or IPN. And the real magic, the thing that ties it all together, is that single, stretched APIC cluster that gives you that unified management. All right, now let's pop the hood and see how this thing actually works. We're going to look at the specific control plane protocols that make this whole interpod communication possible. Now this is an absolutely crucial design principle: fault isolation. If a control plane protocol has a problem inside one pod, say an issue with ISIS or COOP, that problem stays contained within that pod. It won't cascade and take down your entire fabric, which gives you these really robust, predictable failure domains.
So inside each pod, you can think of ISIS as the local GPS. It's constantly figuring out the best paths, so every device knows how to reach all the other tunnel endpoints, or TEEPs. But here's the clever part. To talk to other pods, it doesn't shout out every single TEEP address. Instead, it just sends a nice, clean summary route over the IPN. This is way more efficient and keeps the whole thing scalable.
And if IS is the GPS, then COOP is the local address book. It keeps track of all the endpoint MAC and IP addresses and knows exactly where they are inside the pod. But what happens when an endpoint in pod 1 needs to find an endpoint in pod 2? Well, that's when that mapping information gets shared between the pods using MPBGP EVPN running across the inner pod network. So what about talking to the rest of the world? When your ACI fabric needs to connect to external networks, it learns those routes through what we call L3 outs. Inside a pod, those routes are passed around using internal BGP, but to make sure every pod knows how to get to the outside world, a separate external MPBGP session is built between the spines of the different pods. Okay, so we've covered the how. Now let's dig into the where. We're going to check out the most common ways you'll see ACI multipod deployed in the real world. Generally, you can lump these deployments into two big buckets. On one hand, you've got scaling up inside a single building or a campus, where your latency is super low. And on the other hand, you've got connecting pods across different geographical sites, which is where things like disaster recovery and workload mobility come into play, and where latency becomes a huge design factor. Here's a classic example of that first bucket, the intra-data center setup. Maybe you've got a massive facility and you're hitting that 200 leaf limit, or you just need to connect server rooms on different floors. In a case like this, you can use a simple pair of core switches to act as your centralized interpod network. Now, this is a super common setup for disaster recovery. You've got two data centers connected with direct links, maybe dark fiber. The absolute #1 rule here, the most critical design constraint, is latency. For this to work, for your APIC cluster to stay healthy and your apps to perform, the round-trip time between these pods has got to be under 50 milliseconds, no exceptions. And you can take that idea a step further. This topology builds on the last one. giving you even more resiliency by creating direct, fully meshed paths between 3 different sites. You'll often see this built with dark fiber or DWDM circuits to get that high bandwidth and low latency you need.
For the most flexibility, you can connect your pods over provider network like MPLS. Now, this is a really powerful option, but it's not a free-for-all. You still have to make sure you have enough bandwidth, you have to implement quality of service, and, you guessed it, you have to guarantee that round-trip latency stays below that magic 50 millisecond number.
All right, this is where the rubber meets the road. A huge part of any good network design is thinking through what happens when things break. So let's really analyze the key failure scenarios you have to plan for in a multi-pod world. First up, the classic split brain. This is what happens when that inter-pod network link goes down, and your pods are completely cut off from each other. The APIC controllers in each pod are still up and running, but they just can't talk to their buddies in the other pod anymore. And here's where the system gets really smart. The side that has the majority of APIC controllers, in this case pod 1 has 2, gets to stay in read-write mode. That means you can keep making configuration changes. To prevent any weird conflicts or database corruption, the minority side, pod 2 over here, automatically flips into a read-only state until that connection comes back.
Okay, let's up the ante. What if an entire pod just disappears? A complete site failure? The actual impact of this disaster scenario depends completely on one thing: where you decided to place your APIC controllers.
This really highlights a critical design choice you have to make. If you have a 3-node APIC cluster and you lose the pod with just one APIC, no big deal, the cluster stays healthy. But if you lose the pod with the majority, the survivor goes read-only. Now, a 5-node cluster gives you more scale, but if you lose the majority pod there, you could actually risk losing some configuration data, what we call shards, and you'll need to call Cisco TAC to recover. This is exactly why the best practice is to always have standby APICs deployed and ready to go.
So let's put it all together now. We'll wrap up by looking at the official guidelines for how to distribute your APIC cluster across your pods to get the absolute best availability and resiliency.
And this table lays out Cisco's best practices perfectly. You'll notice a pattern here. The goal is always to spread out your controllers so that losing any single pod doesn't cause the entire cluster to lose its operational quorum. So, for example, in a 3-pod design, you do a 2-2-1 split. That way, no matter which pod fails, you still have at least 3 active APICs online. And there you have it. We've gone all the way from the high-level business drivers down to the details of failure planning. ACI Multipod is an incredibly powerful tool for building data center networks that are both scalable and highly resilient across multiple sites. So the real question to leave you with is, are your business needs and your network architecture ready to take that next step?